Hey everybody, so we are going to be talking about one of our other transformations, and that is a reflection. I want you to think about a reflection just like you look in the mirror, because it's a flip. Oop. Over a line called the line of reflection. And notice the flip is literally in the word. All right, now each point in its image are the same distance from the line of reflection. Think about it. When you look in a mirror from far away, you still look far away in a mirror. If you're close in a mirror, then you still look close in a mirror. Now, there are three types of possible lines of reflection. You can either have the x-axis or the y-axis. These are the ones that you guys learned in 8th grade or whatnot whenever you first took pre-algebra. Vertical or horizontal lines. So remember, vertical lines right here, okay, they have no slope, they are undefined, and they're in x equals. Or horizontal lines, they've got a 0 slope. Okay, so it's just some number and it's y equals some number. Or the third option is diagonal lines in the form of y equals x or y equals negative x. There are formula shortcuts for all of these. So this next problem, we are going to graph the pre-image and its translation. And we've got triangle ABC with vertices A at -4, 2, B at 4, 7, C at 5, 1, and it's going to be flipped on the x-axis, right? If it's over the x-axis, then your x is going to stay the same. Your x kind of acts as an anchor that you're flipping around. And then your y, it switches signs. So if I'm doing this one right here, I've got A at -4, 2, B at 4, 7, 4, 2, and C at 5, 1. Oop. Okay, this is a triangle we're working with. Now, if you're just reflecting it, oops, 4, 7. This way, now Miss Samdi can actually graph correctly. Okay, if you're doing that, then your x value right here is going to stay the same. Over the x-axis, keep the x the same. So -4, 4, 5. Then the other one, your y value, that's going to switch signs. This was a positive, becomes a negative. Was a positive, becomes a negative. Was a positive, becomes a negative. If it had been a negative, then we would have just written a +1 instead. All right? So the algebraic notation for reflections across the axes is, if it's across the x-axis, then it's going to be the x stays the same, and then your other one flips the sign. So x-axis, x stays the same. Right? And then if it's the y-axis, that means that's going to mean that your y stays the same. And that your x is going to swap signs. All right, so remember, this negative means switch signs. It doesn't mean just put a negative in front of it. All right, so now let's flip across some other lines. All right, here is our first example. Okay, we've got parallelogram CDEF with these points here, and it's on the line y equals 2. So we know it's a horizontal line, hoivux, okay? So it's this line right here that we are working with. Now we're used to doing it with the x-axis. So guess what? Why don't we move everything down? Okay, so you're going to take that number away from the y. So we originally had -4, -4, -2, 0, 6, 1, and 4, -3. I am going to first change it. So we've got -4, -4, -2, 0, 6, 1, 4, -3. And it's going to be a lot of rinse and repeat, back and wash, okay? You're going to be going back and forth, okay? So I'm going to move it back so that it goes down to the origin by subtracting 2. So it becomes -4, -6, then it becomes -2, -2, -6, -1, -4, -5. Then I'm going to apply my reflection. And it's a reflection across the x-axis. So now what happens is my x value stayed the same, since it's a reflection over the x. And my other ones, my y, flips the sign. So this becomes a +6, +2, +6, +5. And guess what? Because you moved it down 2, now you're going to move it back up, that 2 that we took away. And we get -4, 8, -2, 4, -6, 8, -4, 7. All right, so all you're doing is you're going to go take it back to the origin, do the application, do the reflection, and then you're going to add it back in. So what stayed the same in this? The x coordinate. To find the y coordinate, remember we had to take away that number from y. Then we flipped. We did a reflection over the x-axis since it's a horizontal line. And then you're going to put that number back. Now, something similar happens when we would do it, say, on a vertical line. What would happen in the vertical line is that your y value is going to stay the same. Vertical line, your vertical coordinate stays the same. So your y coordinate would stay the same. And say you were flipping it over something like x equals 3, what you would end up doing is the same exact thing, except now you're going to do it from the x. So take away that number, the 3, from the x, reflect over the y-axis because it's a vertical line, and then put the number back to your x coordinate. All right, that's the second type of reflection you're going to see. Your last one is going to be something like this, where you've got either y equals x or y equals -x. Pretty much this line, your linear parent function, you're going to be flipping over it. Now, there is a rule for this. What happens then is you are going to instead make it yx. If it's y equals x, it becomes yx. If it's y equals -x, well, that's too much negativity, so we're going to put the negativity on both of them. So I am going to do the square with you guys, and I want you to do the triangle on your own, and I want you to submit this as your work for today. All right, so it says it's going to go to negative y. Xy goes to negative y, negative x. So that means I'm going to swap where my positions are. So it was negative 1, 3. It's going to become 3, negative 1, 6, 0, 5, 3, 2, 2. Well, that's if it's y equals x. Now you got to flip signs. This was a positive, becomes a negative. Was a negative, becomes a positive. You can also just put a plus sign there. Negative, 0 is neutral, negative, 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 negative. And this right here would be your final answer. And it's over this line right here, y equals negative x. All right, thanks for watching.